Okay, let's start. Now, today we are going to talk about a little bit about the L values and R values. I'm just going to start it up, and then you're supposed to study the expressions for next week to come in. I just started up for you, so you kind of get a hint of. So I want to complete something about L values and R values, and then after that, we can continue with the rest of the So let me just tell you exactly, I'm going to bring this up. And let's go over here. So we are going to talk, sorry, that's not you. We are going to talk about class templates, composition, aggregation, associations, finish the whole thing. I start up the expressions, okay? So the next week, the quiz is going to be on introduction, types, and class and relationships. I'll tell you what the questions are going to be. And remember, there's a decision that you have to make on if you would like to have your concept questions for midterm and final to be gradually done, or you want to do it in an hour and a half that you are doing your midterm. I'm going to ask that question. Okay, so keep that in mind. That's the question that's going to come.
The concepts counts the walkthroughs, right?
Pardon me?
The concept questions counts the walkthroughs as well. The walkthroughs questions.
Yeah, walkthrough and concept. Yeah.
Only coding.
Only coding is going to be on that day. Okay, so that's what you're going to do. Okay, so I can put the walkthroughs with programming, but that defies the whole purpose of you doing programming. Because when you look at the test, you will see around 20% of the mark is concept and walkthroughs. 80% is programming, okay? Or maybe 30%, something like that. Very low amount of weight of the midterm and final goes on concept and walkthroughs. And the rest is going to be all programming, okay? All right, so the first thing I'm going to do, I'm going to start off with expressions, but I'm not going to teach it. I'm just going to talk about L values and R values, since we talked about it last time. I'm just going to tell you exactly what L values and R values and their categories are, and that's what expressions begin with, and then you can continue going through it. You have to study that yourself. It's lots of waste of time if I want to go through it. So the next time you're coming in, I'm going to ask you any questions about expressions. No questions, we start the functions, okay? We have so much to cover in functions that it is physically impossible to go through. Expressions are telling you, like, anyways, you read it here now, okay? So expression, your responsibility. I just start off with the explaining of these. We're going to go through it. So we talked about L values and R values when we're talking about expressions. We said L value is something that stands at left, and R value is what stands at right. And that was kind of a cheesy way of explaining what they are. But in reality, expressions are as follows. You have GL value, generalized left values, and then you have right values. These are the two main categories. Now you see these bottom ones. Let me just see if I can. Okay, thank you. Okay, better. All right. All right. So L values are expressions that they have a piece of memory dedicated to them. It belongs to them. They are standing, and they are values that they exist, and they're not going to go away. Like you're saying employee A. That A thingy exists, employees there, you know exactly what you're doing. PR values that are pure right values, let's call it. These pure values are like 10, 20, like values that cannot, literal values, that they can only be at right side of an operation. You can never put it at left side. These are values that they don't have any memory location dedicated for them. They are within your code, and they are, hopefully one day you're going to learn compiler design. We call it in literal pool. So there is a place when the code gets compiled, it puts all the literal values that you put. You're saying for I is equal to 0 and yada, 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 where that 0 goes. That 0 is a value, right? It's a PR value. Where does it go? It keeps that somewhere called a literal pool when it's compiling. So if anywhere else you're using your 0, it's going to use that one. And if you put other literal values, it all keeps them someplace, and we call it literal pool. So those are PR values. X values are temporary variables, the variables that are about to die. These type of values, they can be at left side of an assignment operator. But we know that they're temporary and they are about to die. So these are the things that we need to know. Now I'm going to explain it to you in a second with this code. So again, I apologize that here I have to sit. So we created a name thingy last time. I'm going to reuse that one. So that's our name, okay, that we created. Why the CSTR over here? I think I had the CSTR in here. This looks good. Oh. That's that. Let me just see if. What's going on here? CSTR.h class CSTR. It's interesting. When you copy a code, it doesn't work.
Could be that S is lowercase.
Pardon me?
The S might be just lowercase.
I don't think it's, is it lowercase? Oh, yes. Thank you. All right. Yeah. Now, autocomp. Did I change the source of my CSTR? I think I did. Did I? Yeah, I think I did. Oh, shoot. Let me bring this version up. What did I do? What did I do? Yeah, this is allocopy and copy and stuff. Let me see if I can find the one that I'm using here. Give me 2 seconds. Two seconds, please. Sandbox. No, that is the one. I have to fix it. Anyways, so CSTR, this is allocopy. And this one is again, so let me just change all this to allocopy, I think. Is it the one? No, one. Only one? Okay. Anyways, this is CSTR. CSTR. I'm not going to run it anyway. It's just. All right. So yeah. So that's the name thingy that we created. Yeah, it has the move constructor and move assignment and everything, so that's good. Now, the source code for it was right here. There we go. All right, so that's what I wanted to say. Okay, so in here we have over here A, B, and C. They are all L values, pure L values. No, not pure, it's L value, okay? As we call it over here L value, which means they will not, they will occupy a piece of memory, and they will keep it, they stay alive, and everything is fine and dandy. You can replace the values, you can force the compiler to treat them as an X value by calling move. When you actually put the move over here, it essentially forces that L value to be treated like an X value, okay? Which then is going to be moved. The function getName over here receives a name and returns it. Therefore, a temporary nameless will be passed back. Because it's a temporary nameless, it will be an X value. Okay? Now, therefore, it's going to be moved when it's actually being called. Same thing over here. It's going to be an X value. It's going to be move assigned. When you actually create a literal value, then it becomes a pure write value, which means it's going to it's not going to have any memory allocated for it. So remember, 3 types we have: L value, X value, PR value. Imagine there is an assignment underneath X value. So L value, always at left side of assignment. It cannot be anywhere else. Okay? It can be at right, but it can stay at left side of an assignment operator, perfectly okay. X value can be at left and right, but if it's at left, you have to see why. Because it's a temporary value, its assignment might be useless. As we mentioned before, if I write something like this, name this is perfectly okay, but why? I am setting a temporary object to C, and then it dies. What is the purpose for it? So you need to know why, okay? If I wanted to just print something or use something, a method out of a temporary value, and I create it, it's fine. But remember, the X values can be at left side of the assignment, but you should think why. And finally, PR values are always at right, which means you can never, ever write PR value is set to C. You can't do that, okay? You cannot even overload an operator to do that for you. Okay, when I have something like this, I can overload an operator to do something with it. I can overload the assignment operator to do something with it when I have an object at left. Because assignment operator is a member of name. Something can be done. This is impossible because assignment operator is the only operator that you cannot overload it as a helper. It must be a member. Any other operator, you can actually do it. So this is an impossibility. So that's why I'm saying PR values that stay at right, they can never be at left side of an assignment operator. And move and everything are happening based on what I told you. I talked about ref last time. You can actually convert something to ref. I cannot give you a proper example for it until we get to threads, binding, and functions. There is no use for me over here to actually show you a ref because I can do this. I can write something like A is set to ref B, but it is already a ref. It's not going to do anything. You know what I mean? I can put it over there, but you cannot make an X value ref. It cannot be done, okay? Because it's an X value, you cannot make it a ref. But if you want to extract reference out of something, will come later on in functions, bindings, threads, and things like that, and you'll see then when we need to use ref, okay? But there is not, our knowledge is not enough yet to explain to you what ref can do, okay? We'll come to it later on when we are getting to functions and threads and templates and things like that. So keep that in mind. No use. Okay, so that's that one. That's kind of a thing that I wanted to say. Study expressions for next session. Okay, extremely important to do so. And now let's start the templates. First of all, let's kind of take a look or kind of review what we did as templates in OOP345. In OOP345, we're talking about function templates. That's all we did. We had a little example of a class template, but didn't go through much. We just explained you can actually create a template and essentially ask the operating system to write the code for you. So I'm going to quickly explain what templates are, and I want you to just pay attention to that. And a template is essentially writing the algorithm, leaving the type as a placeholder for the compiler, and ask the compiler to recreate the algorithm for us on demand based on what type is being invoked. We okay with that? So we said when we were teaching OOP345, if anybody wants me to actually teach templates, function templates? Anyone? Or you're okay with it? I can just quickly go through it. I'm getting a yes or a no. No? No need? Okay. Anyway, so for example, in this scenario, instead of creating several different overloads of swap, I'm going to say create a template. Now, in old times, it used to be template class T. Now, because they wanted to now have emphasis that that's actually a type name, now you can write type name. So class T type name, you may see template class, they're identical. Those two lines, line number 3 and 4, are the same. Okay? So I'm saying I'm creating a template of type T, and I want to swap the values of these two types. And then doing so, the compiler will take a look at your code, and at any moment you call the swap, it takes a look at the types that you have, and it recreates that for you on the fly at compile time. So when I say swap address of A and address of B, it looks and sees, okay, A, B, they're double. Therefore, it knows it needs to create this one for you. So essentially removes this one, puts a double, removes this one, puts a double, removes, and removes this one, puts a double. And then it accommodates this one. The next time the swap is called, it sees that D and E are characters. It recreates the exact same thing, changing the T's to character. Therefore, different overloads of the function gets regenerated at compile time. So what is the good thing about this? Why not just overload? First of all, overload, you have to foresee what types you are going to use. You have to foresee what types you are going to use. With templates, you don't need to. all you need to do is to document your template saying, hey, the type of my template requires such and such operations to be working for it. And then any type you use, the template's going to get regenerated for you. Be okay with this? Okay? So that's number one. Number two, when you create overloads, the code compiles and gets generated, the binary gets generated inside your executable, where template only happens if it's used. If I do not call the swap function over here at all, the template won't even exist in my executable because the code is not generated. There is no function. You follow? That's the good thing about templates. And this is ultimate polymorphism. What was the name of this polymorphism thingy? Parametric. Thank you. So parametric. Give it to the next person, since you already asked it. Parametric polymorphism, right? So essentially, it generates the code when you need to. And that's what we did, okay? That was OOP345 to the extent of it. Now, we need to, and in OOP345 we mentioned if you overload a type, so if I actually have this thing over here, the overload supersedes template, which means when double thing, the swap with address of two doubles, that overload will be used and there is no conflict with the template. Are we okay? All right? That was a way of specializing specific things. Like if you want to do an addition and you had two strings and the string addition is different with primitive number value additions, you could have overloaded the thing and specialize it. But again, the whole purpose of a template, which is the code only exists when it's used, will be out of the window. So not a good way of specializing a template. So creating an overload when the logic of your template doesn't answer for a specific type is a way to get over with it. But there is a better way. And that's called specialization. And overloading, you know what I mean, okay? Now, let's say I have a template to find the largest value between two things. Okay? It's a valid thing, right? So essentially, that template says if somebody calls the function largest with the two types, use that trinary operator and return the largest one. You okay with that? Problem with it? No problem? All right. Now let's say I have a class called container. And container has a method called hasMore. Okay? Which compares itself with another container. Now, I want this template to work with this container. I want to be able to use the largest. I want to say largest, so essentially this is what I want to do. I want to write something like I want to be able to write C largest BNC. I want to do something like this, okay? Largest obviously this is not going to work because A greater than me doesn't mean anything for the structured container, right? Now I could have overloaded largest and do whatever I wanted to do to make it work. But there is another way. What you can do is essentially write a template for it. So essentially, I'm gonna write over here template. So I want to write another version of largest that matches a container, and it's going to be only invoked by the compiler to generate the code if this scenario happens. What do? I write template. But in my template, I'm not going to put any type. I'm saying, hey, what you're saying over here is a template, but for a specific type. What type? Then in here, I'm going to say container. OK? And then write the code for it, largest. OK? And in front of the name, I'm going to put the type that I wanted to take effect. So I'm going to say container. And now I start writing the function. Container. Container C1. Container C2. And then in here, I'm going to say return C1 has more C2. And if that's the case, then I'm going to return C1. Otherwise, I'm going to return C2. OK? So this tells to the compiler, hey, there is a template for largest that should only be invoked if the type is container. And that's how it's supposed to be done. Now, yes?
How's that different from overload?
The difference is that if I don't call the largest over here, no function for container will exist in my executable. When you overload it, no matter you call it or not, the code of your largest thingy will be in your executable, which you don't want to. That's the only difference. OK? So if your code is very small and you don't care, just don't specialize it. Just overload it. But if you are writing a systems thing and it's very important for you because your program may be used in 50 different places and so on and so forth, and you want to make sure that your executable remains small, then always specialize your reference. Are we good? All right. All right. Same way, for example, if I wanted this to work for strings to see which one is bigger, which one is larger than the other one, that's going to be the code for strings, for constant character pointers, to return the one that is the bigger of the two, which means comes next in dictionary. So what I could do was actually write over there. So and I have a template, and the type is constant character pointer, and that's the left and that's the right, and string compare between the two greater than 0 will do whatever we are doing. Are we good? OK? So that's specialization, function specialization, template specialization. Now, sometimes let's bring back what we have written. So what if I want to have this? What if I want to have this? So I'm saying A is largest between B and C. And C is a double. Pardon me? No, we cannot do auto. It's a template. Template doesn't have auto. Aha! Good thing. Template cannot do auto because auto is at runtime. Okay? It's not. You can, but we'll talk about it soon. But no, not auto. Yeah, go ahead. So I have two different types? Oh yeah, I could do that, but I don't want to. Let's say that's in systems. You know there is a template over there, you cannot change its source code. I want to make this thing work. How? I want to say, hey, the heck with it. I just convert that C thingy to an integer. There are two ways. Either I could just cast this, right, as you mentioned. Yes, that's called resolving. Okay, whenever you have a template and you want to resolve the call the way you want it, I write this and I want the largest for integer to be called to fix this. And I know when it's called, it's possible because the double is going to get casted to an integer. There's no problem. If you want to explicitly request for a specific version of it to be called, you can actually write it over here. So you can say, hey, I want largest integer version to be created for this. As easy as that. So you can specifically mention which one do you want. Or I could have changed the double one, no problem. Then it would have casted the B to a double and return a double and downcast the double to an integer and put it in A. They were both valid. You could have any way, you resolve it any way you want by adding the signature of the template after the template. Are we okay with this? Are we okay? And all right. Okay. So I'm bringing a code from from OOP345. We created an integer array for OOP345, if you recall. In OOP345, we created an integer array class that created integers, an array of integers. So what we did, we said, instead of using integer array, because integer arrays are not reliable, you don't know what their size is, and you can screw things up. You cannot change. You can, if you pass the index of an array, you got to get segmentation fault, and if the size is too small, then it doesn't work. Then you have to do dynamic memory allocations. That's difficult. So we said we're going to put all these logic inside the class, and we call that class an int array class. So we do all the things that are needed to be done inside the integer array dynamic class that kind of impersonates an integer array. We know an array is essentially a pointer with data pointing to a series of values in the memory. So that's what I'm going to do. I'm going to say it's an integer array, so I'm going to create integer pointer and data. Okay? Then I'm going to say it needs a size, because the problem with C arrays are that we don't know what their size is. You pass it to a function, you don't know what the size is anymore. I want something to remember its own size. Then I'm going to add the size of it. Then, and I want to also prevent the problem that if they actually exceed the size of the array, for the array to fail. So if actually they pass the size, I'm going to automatically resize the array, make it bigger. Okay? So I create a function called resize to any size I want. So that resize function, what it does, it reallocates the memory to a new size and copies everything automatically in it. I'll show you the code in 2 seconds. It's all dynamic memory allocation. We know what it is. It's OOP345. Okay? I set the constructor to default to 1. So if somebody says it's 0, I'm going to make it 1. Okay? I'm going to have a copy constructor and copy assignment. You are going to add the move stuff to it. That's going to be your question for the quiz, so practice it. Okay? So add the move constructor and move assignment to it to just kind of see how it works. I create a size method, so at any moment of time, you can ask the array, what is your size? The array is going to tell you what the size is. There's no problem with that. I create the index operator, non-constant one, that returns the reference of any element that I request. Therefore, it acts exactly like an array. You can put it at left side because it's a reference and it's an L value. You can put it at left side of the thing, so you can literally put the class name and an index at left side of an assignment operator and treat it as you are setting an array element. Or you can put it at right side and extract the value out. And to make sure that this thing works, even if it's passed as a constant reference to somewhere else, I overload the constant integer reference operator, which essentially means it's not an L value anymore, it's an R value. You cannot put it at left side because it's constant. Okay, but you can extract the values out. And I'll make sure that if they go to the end of the array, I kind of loop back or something to make sure they're not going to go screw things up. I create a virtual destructor, making sure that if somebody wants to inherit from it, it's not going to have memory leak, and the destructor also takes care of the memory that is allocated. Also, I add one little thing to it that no array has, which is if somebody prints my array, it's going to print the elements comma separated. Something like that. And I overload the insertion operator so it actually works with cout, so you can actually print an array. We good? The constructor, as I mentioned, if size is less than 0, less than or equal to 0, it sets it to 1 anyway. It allocates enough memory for it. So it essentially says set the size to the size that is coming in and allocate the memory. Any problem with this? I want everybody to look at it, and I'll go to the next one. Copy construction. Because of the fact that I made the constructor not allow any safe empty state, I don't need to worry about it. If an integer array exists, it is valid. Therefore, I don't need to check for validation. Therefore, I'm going to just copy the size and allocate enough memory and put everything from the right to left, so copy constructor is very easy. And I do not like to reuse code, so I just wrote the code for it separate. Are we okay with the copy constructor? Everyone. Take some time. Take a look at it. Copy assignment. First of all, I'll make sure that I'm not copying myself. Then I'm going to delete whatever I have and immediately do exactly what I have done in the copy constructor. So it would have been nice, actually, to, you see these two codes are identical? You see that? That's bad programming. When you have identical code like this, you write a private method. So that's my bad. Fix it. Change this thing so you have a function over here, I don't know, whatever you want to call it copy, whatever, and put that one in the private section as I did for resize, and recall that. That's how you reuse code. That's better than calling operator equal in it. Again, suggestion. The destructor deletes it. There is no problem with that. The size returns the size. And the operator works like this. So I'm saying if the index is less than 0, make it 0. So they cannot go negative. OK? That's number one. I'm going to make sure that they're not going to go 0, 0. If the index is bigger than size, I'm going to say first resize it, then return the index out, right? So what happens is that if they exceed the size, the array makes itself bigger. Nothing to worry about. Everybody's okay with this? Yes.
Some languages, if I'm not mistaken, also take into the operator the negative. This is where you will implement it.
Opera voice. Okay.
Some languages, when you
Allow -1.
exactly.
Not some languages. C does.
Okay.
Okay, in C you can have negative index. My array doesn't have it.
No, but if you were to implement it as usually they do, that instead of starting at the beginning but starting at the end, this is where you will put the logic, correct?
Yes. Oh, yeah. You're saying to put it at the, yeah, sure. Actually, I implemented that one in the next. Okay. Okay, so this is when this one doesn't allow negative because it's an L value. You can actually resize it. It's something that you can put values in it. For the other one that is constant, I cannot resize it because it's constant. Okay? Although I could have removed that constantness. I could have removed that constantness. I haven't done it yet. When we go a little further, how can I remove the constantness? We learned it in OOP345. You remember? Constant cast. We have a templated cast as you do reinterpret cast, and we have one that was constant cast, right? That's to remove constantness. You can explicitly, surgically, only remove the constantness out of pieces of your class if you want to. So I could have resized this thing in this constant one. I could have. I could have created a pointer to the current object, remove the constantness out of it, and called resize. I could have done that. I didn't do it. Okay? Instead, I said, if they exceed the size, get the modulus, which loops back. Right? So let's say if it's 3, and you put index 2, okay? 2 out of 3, it's 2, right? If you put 3 out of 3, it's 1, and 0 is the remainder, so it goes back. If it's 4, it becomes 1, it goes back. 5 becomes 2, and 6 becomes 0 again. So no matter what you do, you're going to stay within. So if you exceed the size of the array, you're going to shoot yourself in the foot, no one else's. Okay, so I designed it that way. And then the display thingy is displaying a comma-separated version of the array. Print the comma-separated version of the array. And resize does resize. We have done that in OOP345. I simply create the new size, whatever the new size is. I allocate that much memory. Then I loop from the beginning up to size or new size, whichever is smaller. Copy all the information from the old memory into the new temporary one. Then I set the size to new size, delete the old one, set the old one to point to the new one, and I'm done. 2 seconds. So resizing can be done like that. That resize actually works both ways. You can actually shorten the size of the array if you want to. But I made it private, so it's not like that. And that one is just make it insertable into cout. Are we okay with this, everyone? It's kind of a reminder of what we have done, right? All right. Now, I want to make that a template. And that's a class template. Why only integer array? I want it to be an array of anything. I have an integer array. I want this to be an array of anything. For that, I'm going to convert a class to a class template, not a function template anymore. I'm going to convert a class to a class template. How do I do that? These are the steps you take. First, as for rules of templates, you are not allowed to have any CPP file for your template. All the code should reside in a header file. Why? Because the compiler needs to know what the algorithm is to generate it. If you create a CPP file and create a header file at compile time, it will only have access to the declaration, declaration of the class, not its definition. Therefore, it cannot generate it. Therefore, everything's down the drain. Because of that, templates as a whole, they're always in the header file. Okay? So the very first thing I'm going to do over here is creating a header file. What should we call it? I want to look at my cheat sheet over here. I've done this so many times, but I don't want it to be like that CS string that we have done. Where did I put it? Oh, there we go. Dynamic array. Okay, got it. So we add a header file. Now that we have the header file, we do that pragma once thingy for now. That means safeguards. Please add the safeguards yourself, okay? Then what you do, you copy all the code that you have, everything in here. Actually, this one has the safeguards, so I'm going to plagiarize that one. So I'm just going to put this one over here. There you go. And in here, I'm going to say dynamic array. Okay? And in the other one, where is the O stream in here? How did it work? Or maybe it never did. I don't know. Anyways, there's no, there should be an O stream in there. So I'm going to say include O stream at the top of it. Include IO stream, and yeah, that's better. All right, now that I have that one, I'll go to the CPP file and copy everything that I have in the CPP file, copy, and put it at the bottom right over here. Okay, everyone? So all the code for those two things are now in my header file. Let me just double check, make sure. And I do not need these. I do not need these, especially using namespace std I'm not going to use. We are in namespace, yada, yada. I'm just going to make sure that we are good. That's deleted. Control K, Control D, if I recall correctly, reformats. So let's look at it. Copy constructor, copy assignment, copy constructor, copy constructor, assignment. That one, operator, operator, display, resize. Looks good to me, okay? So I'm going to remove those two things that we have, int array over here. We don't need it. Remove, remove. No, don't save. Okay? So now I have the dynamic array over here. I'm going to follow the exact same thing we have done in the functions to convert this to a template. But to do that, we have to follow specific guidelines. Is there a question? Huh? No, is there? Go ahead. Is there a question? You're good? You're okay? Are you sure? Last chance. Okay. So the very first thing we do, we add the template over here. Template, type name, type. So I'm going to, and remember, each template only changes the scope that comes after. So that's what it's going to affect. For all the other ones, I have to keep adding. Oh, my apologies. Let me change the name of all the class names over here to dynamic array, because that's what I want to do, right? So I'm going to say over here, dynamic array. Not current project, but current document. Okay. Are we okay? So we change it to that one. Now I'm going to say type. Now, what we need to do is to change the focus of, so let me just write something over here. To convert a class to a class template, do the following. 1, change the focus type, we call it, or the templated. The required type, type to the placeholder of the template. I'm going to change that one to T, capital T, because I use type. I don't want it to be confused. So type name is T. So I have to look for all the things that is going to be generalized to any type. I'm going to change that to a T. Okay, so if I want an array of integers, I have T as an int. If I want it double, I have to have a double. If I have an employee, it has to be an employee pointer. Okay, so when I look at it, when I just come over here and look at it, the very first thing that I see is right over here, right? So instead of a pointer to an integer because of an integer here, that has to be a T pointer. Are we okay with this?
Yep.
It means anything. This int, should I change it to anything? No, it's the size, right? And let's change it to C++. Let's make it size T, right? Just to make sure that we don't make any. That one was OOP345. We had int. Now we are having, and that cannot be negative because of that. Okay. Now resize. It's going to resize it. That's going to be size T. The reason that I do that, I want to make sure that we know exactly what is being changed. Now in here again, it's going to be size T, and I'm going to say set it to 1 by default. I have a copy constructor, copy assignment. Integer size is returning size T. Now, what is this int? Should I change it? What does it change to? What does it change to? T. Why? Because it's returning the element of the array, right? But this one is an index. Index has nothing to do with that. That's size T, right? Now we're going to come back over here. What is this? Constant. That has to be a T because it's the element. And this one is a size T. Are we okay with this? The destructor, fine. The display, fine. I don't think in here there is anything else needed to make this thing a general type for any type of array. Right? Are we okay? So that was step 1. And we have to do this to everything. One by one, I have to add template T to every single scope and go. And I can start right with this at this moment. So right over here, so even those who are only one line, I have to write over, and it could be anything. I can write over here template, type name, doesn't matter. As long as it's for that scope. But it's better to have the same type, okay? So that only applies to line 29. For the scope of 31 to 34, I have to add another one. And I have to keep going like that. But I did only one rule. Let's go through all 3 rules. And then we'll continue with the rest, okay? Rule number 2. Rule number 2 there are actually 2 rules, and rule number 2 has 3 parts. Number 2, you have to add the type of the template as a signature to the names to all the class names. Why? This is the reason. Let me come in PRG and write something over here. Let's say I have a class called container. And I want to create a dynamic array of containers with the thing that I created. With that, let's assume that the implementation of the template is complete. If I want to actually create a class of that, what can I do? So the name is dynamic array, right? Dynamic array. And then I want to create a dynamic array of containers. Say 20 of them. The problem is that, unlike functions, classes don't have signatures. A function has a signature. The compiler can look at the signature and identify what to create. Classes are not like that. They don't have signatures. Therefore, you have to always act as if you are specializing them, like you did for the function templates. We put the signature to the name of the thing. We do it over here. So I have to say dynamic array of type container, and then create the template out of it. Because the signature must be carried so that the compiler knows what type of a class is being passed, we have to add that signature to every single class name with these rules, not for all of them. Number one, with these exceptions. A, do not add to the name of the class right after template. So you don't add it to this one. That's the first exception. Number two, do not add to the constructor names. Why? Because constructors are not functions. Their name doesn't carry any significant thing. The name of a constructor says when it's supposed to be called, when something is getting created. It's not a function. Because of that, constructor names should not get the signature. Also, do not add to the destructor for the exact same reason. Now let's go through it. This one, I shouldn't add. Dynamic array, that's a constructor, right? I don't add. This one is a constructor, line number 23, right? I don't add. But this one is not a constructor, it's an argument. So I add T to it. This one is the return type of the operator equal. It must carry the signature. This one is an element. It must carry the signature. Here is fine, fine. And this one is a destructor, so nothing should be added to it. Done. Now my class is actually completed. Let's come over here. Do I have any dynamic array? Yes. Is it constructor or destructor? No. So it must carry the signature. And that's it. Next one. Now get ready. For each function, the person with the microphone is going to tell me what to change. I'm going to do this, and the next, it's going to be you. OK? All right. Not this one. The next one is going to be you. OK? So template, type name, T. So is this the constructor name? No. Is this the constructor name? Yes, so I don't change it. And it's a good idea to actually write template instead of template. OK? Somebody help me spell. OK. All right. So template, yada, yada, dynamic array. Why is it giving me an error? No instead of yada, yada, then matches this. Oh, size. Thank you. It's size T. I caused trouble for myself. Now, in here, what do I have? I have new int, correct? So that is supposed to be T, not int. So that has to change. And right off the bat over here, you have to mention what? When you get to a place that you see something iffy is happening, if you can create an array of a class, it means that array for sure has, that type for sure has what? If I can create an array of employees, if I can say employee A10, semicolon, employee must have OOP345. Oy, 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 oy. When you say employee A10, what happens? Analyze it. When you say integer A10, what happens? 10 integers will get created, right? What will they be set to? Nothing, right? Right? Now if I create an array of 10 employees, what they will be set to?
Whatever the constructor is set to.
Which constructor?
The default.
Thank you. So if a class doesn't have a default constructor, you cannot create an array out of it. Because when you say employee A10, 10 employees are going to get created. And you didn't mention how. You cannot create an array out of it unless you initialize it. So right off the bat, that's the documentation of a template. When I say each template must carry documentation, that's what it is. So when you are giving this thing to the client, which is other programmers, or you want to reuse it, you have to look at this documentation. To use this template, the type of the template must be able to be defaulted. Otherwise, this template is not going to work for it. Got it? Am I making sense? Okay, so right off the bat, and these are the important stuff. As soon as you see this, I have to say T must have no arg constructor. Okay? Are we good? Are you ready, my friend? A little bit, that's okay. We'll go through it. So, template. Template. Type name, T. So line number 42. It is actually telling you which ones need T. The wiggly ones, right? So the first one needs T. How about the second one? Does this need T?
No.
How about this one? Does it need T? Does this need the type?
Yeah.
Yes.
Yes.
All right. Now, what else need to change to? What else need to change to type? Give me line number.
44.
Loud.
44.
44? 44?
No, I mean, like, question again?
This one?
No, like.
So 43.
No, 43 first.
Oh, 43.
Yeah,
so this should change to T. That's
T.
perfectly good. And again, we have to mention the same thing. T must, or you can make your life easy at the top. You can actually write something like this. You can write over here. Template requirements. T must have no arg, constructor. By the way, the question in the quiz, I'm going to give you a class, and I'm going to tell you convert it to a template, and you have to put those documentation for it too, what things are needed. So these are the type of the questions that you're going to see. Okay, what is the next thing? So line number 43, and it's a good idea to change this to size T so we don't get warning. I think we're good. Does it need to change anything? No? Give the microphone to the next person, please. So what do I change here?
The first one,
Yay or nay?
Yes.
Okay. Second one?
Yes.
Third one?
Yes.
Fantastic. Now, line number 63?
Size T? No, that's going to be the T.
63.
Uh-huh.
Do I need to change it to T?
Yep.
Yes. This one will change to size T. I hope you understand why we are putting T over here, because it's returning this. It needs to know which type of dynamic array it's actually returning. Okay? My lady, it's your turn. Yes or no? Change it? Add?
I think yes, we
Yes.
add T,
Okay.
but
Do I
not
need
for
to
the
add this
second
one?
one. It's this destructive.
Destructor, we don't need it, right? Yours was easy. You can give it to
Yes.
the... Template. Type name, T. Do we need to, no, but this is size T, because it's the size of the template. Does this one need T?
Yes.
Yes. All right. And again, easy one. Yes. 64. Oh, that's. I thought you want. I was just about to give you 2% for your midterm, but you missed it. Anybody else wants to comment anything about line 30, 64, 65? Anyone? Another documentation needs to be added. I have an element being set to another element, which means copy assignment should be implemented. T must be able to be copy assigned. Right? Right? Well, thank you very much for the observation, because I saw that. And I just thought, I'm going to, anyways. So yeah, so because I have an assignment over here between two types, I need to mention that, hey, assignment must be defined for this. So yeah, so template. Seriously, template, type name. T, okay. So this one?
Yes.
Yes. This one? No?
Yes.
It's a binary choice. When you see I go like this, definitely. Okay. This one? Yeah, it's size T. Okay? Now I don't need to make it less than 0. So this condition is not needed anymore. If it's less than 0, it will never be less than 0 because it's size T. All right? So that'll be removed. Do we need to?
Yes.
Yes. Need to?
Yes.
Need to?
Size T.
Size T. All right. And again, index less than 0, we don't need to, because it's size T. Template, type name. Oh. I know it's boring, but believe me, this will help you. Okay. So, for this one, do we need it?
Yes.
Yes, sir. Display or stream const, operator 0, size T. We don't have anything. That was an easy one. There's nothing over here to change, right? Okay, good one. Yes. Okay, so template. Type name, T. Okay? So, do we need anything here? Yes. This is new size, so it's size T. Now, do we need to change this to temp, to T?
Yeah.
How about this one?
Yes.
How about this one?
Size T.
Size T. And here, we just need assignment. We know that. Assignment, 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 everything's assignment. Now, I have done, thank you. I have done something over here that I do not like. I don't like functions returning void. That misses an opportunity. I always, in a class, when I have a void function, I always make it always return the reference of the current object. It gives me the opportunity to cascade if I want to. And if I don't use it, it's just there. It does not, because it's a reference, nothing happens. So now I'm going to come down here. And for the resize, I'm going to change this to dynamic array T reference. And I'm going to return this at the end. OK? That's just a habit that I have. Now this one. So we're going to have template, type name, T, and do we need T over here? Yes.
Yes.
And the rest is good. So I think we're done. Now we have a dynamic array. The gentleman over there. Yours is going to be cool. We're going to come. You'll see it. So that's going to be. So now we have a dynamic array. Let's go over here and see if we can actually do anything with it. Will it work or not? So in here, I'm going to create this. So I'm going to create 4 containers. And I'm going to go from here to size. One by one, I'm going to set it to a value. And then I'm going to print it out and see if it's going to work. OK? Fingers crossed. Oh, did I include dynamic? Yeah, we did. Yep. So I don't know. Why is it out? Get back in. Sorry. There we go. There we go. Now I have a dynamic array of containers. And you can make this any array now. I can have a dynamic array of doubles. And the good thing is that now I can actually do this. I can say for I set to 0, I less than 30, and I plus plus. And I can say di is set to I plus 1 multiplied by, I don't know, 10.22, something, just a double, eh? And then I'm going to go see out D. Because I'm passing the size and going more than 20, it should resize itself to 30, and it failed. Good. So, did it fail? It means resizing didn't work. Don't tell me that the compiler is actually not allowing me to do that. OK, let's make it easy. So I'm going to put 2 over here, and I'm going to put 5 over here. And then we'll walk through and see what's wrong with it. This is double. That's double. That should work. So let me come over here and see what's going on. So let me run it one more time. Hopefully it's going to fail. Yeah, it crashed. No. Yeah, it crashed. Did it? Yeah. So let's go through it. I'm pressing F5 to run to that point. So now it's here. Now I have 0. OK, so I'll go up over here. Oh, it's going to the constructor. Why? What the heck just happened? It's going to the constructor. and putting 10 for the size. Oh. Holy schmoly. You know what happened? Okay, I'll tell you what happened. This is interesting. We overloaded the... My goodness. Okay, let me tell you what happened. It's something that I have to fix somehow. Okay, let me see what happened. Let me tell you what happened. So, at left side, this is amazing actually. At left side, I have the array, right? And at right side, I have a double, correct? And I have an assignment between the two, right? Down to this point, we are okay? So, from what we have over there, we said I can actually put that double at left side of an assignment, hoping that this will be called. Correct? No, not that, sorry. This will be called. Putting the value at left side, correct? Huh? No, it's, see, the index is going right. So it's actually going with the index. But the funny thing is that it's actually calling a constructor of the, let me see what's going on here. Oh, did I make a mistake? Oh, I am an idiot. Can anybody tell me what did I do wrong? I just found out. Huh? Pardon me? Line 21 is the correct one. Line 20 is wrong. Instead of creating an array with 2 elements, I created 2 arrays with 1 size each. Remember, that, oh my God, how did I do that? You see this? I created 2 double arrays, not an array with 2 elements. This is an array with 2 elements. You see what happened? And that's why in here, it was trying to set each to another double, casting this to a double array, creating in it an alt, you know what happened, right? So now let's see if it's going to work actually. Was that the reason? That was interesting. I love that. There you go. So that was my problem. So instead of actually creating an array with size of 2, I created 2 arrays with size of 1. And every single time, it was setting one of them to a double and casting the double to an integer, creating a temporary nameless double, using the assignment operator to go, phew. Okay, yes.
So it was just the difference was parentheses versus square brackets, right?
Yeah, I made a
Okay.
boo-boo. Yeah, I made a boo-boo. I put. So now I can go. So that was cool. I love it. Okay, so now in here I'm gonna I can put 30 and hopefully everything's gonna be okay. One more time. There we go. Are we okay now? Okay. All right. That was funny. All right. Okay. So so we have a dynamic array. And that's templates. You see this class template? I always say this when I finish this. It used to make sense when Apple had that slogan. Remember at old times, Apple would say, "You want it? There's an app for that." They would say, "You want this? There's an app for that. You want that? There's an app for that." Anything you want to do in C++, there's a standard template library for it. There's a standard template for it. Anything. You will see. Even if you want to do a loop, there's a template for it to do the loop for you efficiently. So you will see, okay? We're going to come to it soon. But that brings us to Let's have a break. I don't know, my head hurts. You guys are okay? Break, 5 minutes? Okay, I'm gonna pause and see what I'm gonna do next before. Zoom and resume. And 1, 2, 3, yeah, it's perfect. All right, so two things I have to mention. First, your final assessment. You guys are ahead compared to the other class. If you look at, you have like 6 sessions, the other one have 4, which is kind of to our advantage, because the Friday in which you're supposed to have your final assessment, I think that's Good Friday. Therefore, is it? I don't know. Good. I know. Anyways, which means your test is going to be on the week before. Let me show it to you. Pardon me? Final assessment. So it's not Good Friday. Maybe I made it. Sorry, I'm not good in these things. It's something. There is a holiday on a Friday. It's not. Sorry, it's not Good Friday. It's good because it's holiday. I don't know. Sorry, I'm very bad with these type of stuff. I'm very bad. Somebody told me something about Good Friday, and I just assumed that's the one. So what's happening in Good Friday? Anybody knows?
Friday's April 18th.
18th? So it is Good Friday. So I was right. So why you said 3 weeks? Okay, so you're worse than me. Okay, so let's put this. Let me just. So calendar. So essentially, if we go up to, did I go? Wow, I went too much. Dismiss all. So if I go to, so week 7, 8, 9, 10, 11, 12, 13. You see, you don't have this. Therefore, your test will be on the 11th. Okay, so your final assessment is going to be on the 11th. Remember that. Okay, I will post as an announcement, and the other class is going to be on the Monday, I think, or no, Tuesday. So they're going to be on Tuesday. You're going to be on Friday the week before, but you're a session ahead anyway. So we're okay, and it ends halfway through. So yeah. Anyway, so just letting you know. That's that one. Now, I had prepared, I wanted to do some data structure introduction for you guys. So I just wanted to implement a stack for you as a template, and then give you a cue to convert it to a template yourself. So probably the next day you're coming in, or if we have time, I'll do that. But we don't, I wanted you to see what data structure is, and then appreciate it when you are using the standard template library that does that for you. But we don't have enough time. So if I find some 15, 20 minutes somewhere, I'll show it to you, so I'm not going to go there. For now, I'm just going to talk about relationship between classes to tell you like how two classes, the relationship between two classes, how you can, the two classes who have relationship with each other, what those relationships are and what shapes they can get, and then give you a code that I have written a long time ago, and I want you to go trace it at home, see if you can understand how it works. All right, so let's do that. When you have two classes involved with each other, these two classes, if two classes if two classes can exist independently. But yet they have relationship with each other. We say these two classes are in association with each other. What does it mean? Take a look at these two classes. I have a class called student. Student has a name, and it can get instantiated, okay? Then I have a class called teacher that has 45 pointers of students in it, which means a teacher teaches to 45 students. The destructor of teacher has nothing to do with students, which means a student can exist on its own, a teacher can exist on its own. You can have 3 different teachers, I can have 500 different students. Students and teachers independently can exist. But I have a relationship with you as I am your teacher and you're my pupil. Are we okay with this? So if tomorrow a car hits me and I die, nothing happens to you guys. You're all perfectly okay and probably happy. Are we okay with this? Right? All right, good. So everybody says, yes, yes. Okay, so that's, and as you see, that's how it's implemented. So you can add a student to a professor. The only thing that the professor is doing, it's pointing to that student, which means I know who my student is, and that's it. There is nothing else happening in here. Are we okay with this? Or if I had a dynamic array of students in here, it would, yes. Oh. Oh, thank you. It was before though, right?
I have no idea. I only joined that for it.
I hope it did. Otherwise, it would be I think it did. We'll find out. Okay. Anyways, I have a backup. So the other one is actually recording. So if that happens, I'm going to, anyways. So is it better now? All right. So as I mentioned over here, I have a student. Student can exist of its own. All the teacher has, is a series of, I could have actually used the dynamic array over here, it would have been cool. Okay, so I have a dynamic array of students over here and so on and so forth. And in my destructor, the dynamic array would have been destroyed and so on. So the pointers get destroyed when the teacher is gone, but the students still are there. Are we okay with this? This is called an association, and that's the implementation for it. One class has relationship with the other class. Neither of the two classes have any ownership or any access to destroy the other class or deallocate the other class. Are we okay with this? That's association. And the example was over there saying I have Marcus as a student, and then teacher F, Fardad, add student, yada, yada. And when I delete Fardad, it will not remove M, the student. Are we okay with this? Okay. Oh, why did I call it A? It's not A, it is A, B, C, D, E, F. Okay? Now, picture, library, and their books. By definition, books exist. The book, you can have a book. And you can have a library too. A book can be in many libraries. But if you burn down a library, the books inside the library will be gone. It doesn't mean that all the books of that type will be gone. But the books inside the library will be gone. This type of association, this type of relationship between the two, where the library manages the books inside of it, but still the two can exist independently, is called an aggregation. As you see over here, when the library is going, it deletes all the books inside. And when you're adding a book, it just doesn't point to the books. It creates a copy of the book and keeps it in itself. You follow? Are we okay with this? This is called an aggregation. I called it F again? Seriously? What's wrong with me? E, F, G. Next one. What is a house? A house is essentially a collection of rooms, right? Inside a house, you have lots of rooms. Correct? Have you ever driven and say, oh, a room? You never do that, right? A room, this doesn't exist by itself. Room must be inside something. It just cannot exist on its own. Do we understand that? So how do we implement that? You have done this in OOP345NAA, but I'm going to do it over here too so you see what I mean. Oh. So as you see, room of mine, it has a name, it has a constructor and everything, but the constructor is private, which means no one can instantiate a room. Room is a friend of a class called house, which means, remember OOP345NAA, remember where I told you what friends are for? Knife in the back? Friends, knife in the back. Remember that? I said you are never allowed to use a friend for a, unfortunately you have it in one of your assignments, but hey, like if you see friendship with functions, a method that is a friend or a function that is a friend of a class, that's bad design. Friendship with respect to classes, one class being friend of another class, that's ownership. It's not friendship. But they call it friends because people who wrote C++ were friendly people. They should have called it owner because that's essentially what it is. Okay, I always give this example. I have a dog and I love her to death. But I always give this example. He says, dog is my friend. Everybody says yes, but I said you can take it to the vet and put it down. It's not your friend. You own it. Okay? We call it friendship. It's not. It's ownership. House owns rooms. When house is created, you add rooms to it. It can instantiate a room because it owns the room and it has access to its constructor. No one outside of a house can build a room. So you have to have a house to have a room inside. And when the house is gone, all the rooms go with it. This is called composition. Composition is when something is composed of something else. You have used composition since C language. Can you give me the example for it? The best example for composition is an array. An array is composed of its elements. You can never say, that's an element. You can't do that. An element only exists if it's inside an array. And when the array is gone, the elements are gone with the array. That's composition. Are we okay with this? So these are the three relationships we need to understand. Association, objects deal with each other. Fine. None of them have access. None of them has anything to do with each other's existence. They can separately exist, and they can relate with each other. We have aggregation when one object starts managing another object, it creates copies out of it inside itself and destroys them when it's gone, but it has nothing to do with other classes. That class can exist somewhere else. It doesn't belong to this one, but when it goes in here, it manages it. So when one class manages existence of another class, but their existence is not enforced by the other one, that's aggregation. And composition is when a class cannot exist anywhere other than inside another class. If that's the case, that's composition. Are we okay with this? All right. Now, the aggregation, I have written something for it. And it all started when one of my students said, it has nothing to do with aggregation. It was intended to demonstrate how manipulators are written. Manipulators that you do in C in and C out, you know what a manipulator is? You say C out and you say set W3, and so it sets the width within the thing. What is that in there? That's a manipulator, right? Or you say left, you say right. So it kind of so I created manipulators for this, but I'll put the example, but it's a good example of aggregation. So I'm going to bring it up. And I want you to, I'm going to quickly explain what it is. And I want you to go home. We are section A, correct? Yeah. So I'm going to add another project in here. Add existing project. So the book and a library, I actually created it properly. Cancel. So this is H composition. Set as startup project. So as you see over here, it's a if you look at the class diagram, this is what it is. So hide subcontent, that's a manipulator. IOable is an interface that says that this thing is input-outable. Title is something that is IOable. I have a library and I have books, and they are in aggregation with each other. When you look at the program, you will see how it works. So I create a library, Vaughan, Toronto, Yorkdale, and I create books. Then I create an array of pointers to those, and I show them one by one. So when I actually run this program, it works as such. So I'm going to bring it to the left, and this one to the right. So as you see now, libraries are getting created, books are getting created. This is a pointer to those 3 libraries. This is a pointer to these 7 books. Then I'm going to show the libraries. It shows the libraries. You see that? Now I'm showing the books. These are the books. Now I'm adding the books to the Vaughan library. Now I'm adding these books to the Toronto library and these books to the York library. Now when I show the library, it shows the library with books inside of them. When I show the book, it shows the book and the libraries that you can find them in. That is a perfect example of aggregation. Now I remove, it's going to remove the books from the Vaughan library, but the other books in other libraries exist. And I can, yeah, so the same thing. Now if I actually show it, you will see. So how it works, and I want you to actually go home and walk through it and see actually how it works. Go through the definition. Everything's over there with some comments here or there. This is the library. This is the book. Go through it and see how it works. And then maybe I'm going to go through it. So it's a good example of how a cool C program is written. Okay? Questions? Suggestions? Yes.
Is there already a consensus on how we're going to do it? If it's all at once or split?
No, I'm going to ask it the next day you're coming in. Okay, so again, think about it. You want to do the quiz, the concepts for midterm and final gradually, and then have lots of time to do the programming, or you want to do everything together. It's not going to change the number or the volume or how complicated the questions are. You're just going to have more time. That's all. And yeah, that's it. Okay, but walkthroughs are within concepts. They are not in the program. Yes? Pardon me? Dash do. Write the thing and write dash do at the end. It tells you exactly when the due date is. I think it's the 2nd. Huh? Yes. It's inside the thing. It's inside the... So this is what you do. So this is what you do. Give me a second. So you go to the course content. Then in here you have workshops and practice. 3, 4, 5. This is assignment. Okay? And do the dash do and you see what it is. I may change the due date a little. Well, it's not a guarantee. But I'm going to take a look at it and see how far we went. What is it covering? If I see it's something that I taught it recently or you need lots of, then I may postpone for all of my classes 1 week later because I'm slow at the beginning in 3, 4, 5, and then we accelerate. So it's possible that you're going to get something, but don't trust on it. Work on it as if the due date is what it says it is. So this is 24th. It's like due in a week now. Okay. Any questions? Again, dash do, please. Did you dash do? Did it work? Have you tried? No? Nobody? Seriously? Okay. All right. Have a beautiful day, everyone. Oh, and let me push it right now so I don't forget. Thank you. You didn't have a chance to say anything, so next time it's going to be your turn.